this is day 9 of Leetcode 75, and we're doing maximum average subarray 1, and this is problem 643. So you're given an integer array nums consisting of n elements and an integer k. We have to find a contiguous subarray whose length is equal to k that has the maximum average value, and return this value. And any answer with a calculation error less than 10 to the negative 5 will be accepted. So the constraint is that k will always be less than or equal to n, and this is an example here where we have k of 4, and we need to find 4 contiguous elements in this, or a contiguous subarray with 4 elements that is the maximum average value. So we can just take this 4, that would give us like what, 13 minus 6, like 7, like 2 probably. Yeah, 2. And then you go to the next one, which gives us 51. And then you go into the next 4, and then you get like, what is this, negative 11, negative 8, like 42 or something, which is not large enough. And you just divide it by the number of elements the number of elements inside of that subarray. Same thing, if you have nums like it has 5, only one element named 5, and then you have k of 1, then you just take 5 divided by 1, which just gives it 5. Okay, so something we can notice here is that what we have to do is that we have to construct a subarray of length 4, and we just keep moving this along until the end of the array, and it has to be contiguous, so you can't do like 1, like, you know, like 1, negative 5, 50, and like 3 or something. It has to be contiguous, meaning that the elements need to be next to each other, or it needs to be like in a sequence essentially. So this is called like a sliding window problem, which means that you just iterate through the array and you just keep moving this window along across the array as it satisfies the minimum requirements. So and another thing here too is that we just need to we honestly can just get the maximum sum we find in the subarray, and then afterwards we'll take the average, because we know that this will always satisfy, since this is always like a constant factor, which doesn't really like affect, you know, we don't have to compute the average every single time. We just need to compute the sum across the subarray. So we can take the result, which is equal to the current, as like we'll have one, that the resulting one, which is like the maximum average, and or the maximum sum that we can find, then the current, which tracks like, oh, this is like the current sub array that we're looking at right now, and compare that against our resulting one. So we have res, and we have the current, which is equal to nums up to k, right? And we already told that the constraint is that k has to be less than or equal to the length of the nums, so that shouldn't be too much of an issue. We don't have to check like whether the length of nums is going to be greater, less than k or anything like that. So afterwards we're going to iterate through the rest of the list, so k up to the length of nums, and then we're going to set our current to be equal. So basically, like, we have up to, so say like for this nums right now, we have up to, you know, k, which is 4. So we have this, which is 2 that we said. Now we want to bring it up, so all we have to do is subtract this current element, or sorry, we have to add this element 50 and subtract 1 to get this next sequence. Right, so we can take plus equals nums of I minus nums of I minus k, which just gets us back to down here. So I is going to be 0, or sorry, I is going to be like 4 or something, so we can add this number 50 and get rid of 1 here. And then afterwards we'll take the result and get the maximum between the current result or the current value, and then we can just return res divided by k. Oh, the sum of 2k. There you go. And that should be the solution.